Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my tutorial series on the DIY Metal Router 2. So I'm going to start releasing these videos as they are taking up quite a bit of hard drive space, and it's been about a year since I've uploaded to Legit Tech Tutorials. So I'm going to try to get this and all my other content uploaded. So the idea is I'll have at least one per day for maybe the 5 days during the week, and then when I during the weekend I probably will work on other projects, and so at that point I'll probably release some older videos, and then that will probably have I'll probably have plenty of content to release that over a long period of time, so we always have some fresh content. So this guy with the DIY Metal Router 2, we have to get this guy done in a very, very quick amount of time. And also, I did do something to show you guys. I showed somebody else this to kind of get an idea of kind of this rotating assembly that we're trying to do on this, as well as other parts here. Let's go ahead and show you that rotating assembly that this is built to cut. And then of course these are identical, they're just flipped around. So this is basically what that will look like. So this is basically the rotating assembly here. So if you notice, each of the blades are indented compared to each other. So this is 15 degrees all the way around. And there are 12 blades. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 blades on this side, 12 blades on the other side. So this side goes like this, and the other side goes like that, right? So they're opposite. And then this guy will have a hex on it at the end. Probably, yeah, it's a hex that will just work with any socket. And a hex is going to be stronger than a square because we're going to have more meat on this than a square. So, and it will fight shearing a little bit better. So this guy is going to be, again, cut all as one piece. So this router that we're building here is going to have tiny little end mill. It's going to go in there and go cut in here and cut all this stuff and get this all cleaned up, right? And these are all the same diameter, even though they don't look it when you see the blades here. So this is going to be on a fourth axis. The fourth axis is going to rotate, going to come around and start, cutting into here and stuff. So I'll probably use a ball end mill most likely, just because I don't know how well a square end mill is going to do at getting these shapes here. So ball end mill will go in, and then maybe I could go with a square or a bullnose. I just have to get, well, maybe I could just go with a bull, no, because I don't want this to be that way. So I'm going to have to think about it. I'll probably do square, but obviously if you do square, you can't have this. Unless I have a small little bullnose. If I have a small little bullnose, there's going to be a radius in here. So I'll have to see if the teeth are going to clear. But the teeth should, because this basically goes up to this point here, and then the teeth go in half an inch. But there's way more than half an inch here. I think, yeah, there should be way more than half an inch there. Yeah, it's almost 0.1 inch. So maybe that is a good idea to have a bullnose end mill go in there. Bullnose end mill will probably be this diameter, this radius here, 0.88. Probably get something more than that, but I have that radius there, and put radiuses everywhere so that they don't, so that stress doesn't concentrate around that area. So this thing would be even stronger than having these square openings, because again, this doesn't need to go in that deep. Because on my CAD model, I have this side and this side just overlapping just barely. So to have some fillets in there would also be pretty nice, even if they're like, well, 0.88. That's pretty much bull nose. I mean, that's pretty much a ball end mill, right? Because that times 2 is pretty close to the diameter. of an eighth of well, it has to be a 1/4 inch, right? So yeah, it's about half. So yeah, that would be a decent sized bullnose. Diameter is 0.176. So that's 0.6 flat, about, right? Or 0.8, sorry. Oh, almost 0.7. Let's get a 0.7 flat section, and then the rest of it's rounded. So yeah, so that's what this router is basically going to do, is come in here and machine all this. And I've kind of started working on the cam for it. I'm still working on it. So here's setup 1. But, whoa. Oh, this is wrong. That's why. Don't want to mess with that. Oh yeah, and this is that side. Oh, I don't think I wrapped on this one. Wrap toolpath, wrap cylinder. Yeah, so I have a lot of issues with it not wanting to unwrap, but it will unwrap, it'll wrap this. I mean, so if I do this, I do geometry and I do that, and I don't, and I wrap this, it'll actually be able to unwrap it. But the issue is that it's not actually going to cut the blades out. It's just going to cut everything all the way down to that square. So let's go ahead and open up. So I basically want to finish the design of this machine by Saturday. Saturday I'm going to Hawaii, so I want to finish that. So in Hawaii I could order all the parts so that they're there when I get back, so I could start building. You see here that the lines go right through this piece here, which is not ideal. All right, so let's go ahead and jump back here. So I'll work on this cam to get to work in here, and I think this is on. So this is with the 8000, which was a different spindle. So let's say it's 18,000 at let's say 0.0012. So machining time, an hour and 27 minutes, which is pretty long. So I'm gonna say probably to do the whole entire thing is gonna take about 3 hours. Obviously this times 2, so that's 3 hours plus a little bit for some other various parts. So I'm gonna say 4 hours. So normally on the water jet, I think it was 300. What was it? I think it was like $300 or something like that to cut, or 200 or something. So $200 divided by $3 a minute. So it was like 100. I think it was like 110 minutes or something like that. 110 minutes or 120 minutes to do one. So compared to a water jet, yes, it is longer, but it'll already come square and sharp, and it'll already be assembled. So I just pull it off. I put the 2 rotating assemblies together. I push the bearings into the little pillow block things, into the pillow blocks with the supports. I push them in there, and then I weld it shut, basically. So that's pretty much all I have to do to get this guy to be well on its way to working correctly. So let's go ahead and let me show you this simulation really quick. Super cool. So I'll just go sideways here. So you can see that the heads, that this cutter is moving, but in actuality this is moving, because you can map this to the what's it called? You could map this to the rotary instead of to the head. But it's pretty cool that we got it down to an hour 27, because before it was a really, really long time. Alright, so let's go. That's basically what we're machining here. So let's go ahead and save this. And then we'll drop it. So now you know basically what we're making this for. Alright, so basically what we're going to do for dimensions is, as far as right now, this base looks pretty good as far as the starting dimensions here. And then we'll find a model for some of these blocks and put it in there, but we'll wait till later till we add that in these high wind rails. So let's go on AliExpress really quick, but we do need some dimensions to create other stuff. So what were the ones that we said? The 5 HGH 15. Let's see. HGH 15CA. These are decently big. Let's see, what's the length of the pillow block? Is 40 millimeters. Whoa. 40 millimeters is 1.5 inches. So I have my calipers here. Let's go ahead and show you guys this. 1.5 inches. Well, that's a big pillow block. That'll work. So that's this here length. Oh, is it length 1? Oh, overall length 61. Whoa, 61. Yeah, that's pretty big. Again, this doesn't matter too much as long as the two pillow blocks combined are less than the size of the router head. So that's another thing. So let's go ahead and look at this. So we're looking at a 0.8 kilowatt or an 800 watt spindle. Something like this. This is what we're looking at with a VFD. And this is probably the one that we're probably going to use. So I think I'm logged in. I'm not logged in. Let me log in here. Let's just go ahead and add this to wish list there. So, and we could do 110 volt. Let's see the diameter here. Less than 0.05. Less than 0.005. So that's 2/10. I'll take that. 65 millimeters. 65. So, ooh. So that is basically how big two pillow blocks have to be. Or I guess technically you could only have one pillow block, but that one pillow block would be okay too. But we want this to be really, really big then. So we don't have to have two pillow blocks, we could have just one. So this right here, length of 61.7. It's really, really close to this. So that's pretty good. But plus we're going to have this rail. So if we have something like 77 is probably going to work. 78. 3 inches, that's probably going to work. So let's look up this one. HGH 20CA. This is too big, but this is okay. HGH 20CA. No, that's HGR. Okay, so let's add that to the Trello. HGH 20 CA high wind rails. And we want a 800 watt spindle, 65 millimeter diameter. And let's go ahead and post this. Oops. Yeah, there we go. Then, there we go. Okay, so HGH. Okay, so that's basically the identifier for the block itself. So the only other thing that I would look for right now is to see if I could find one that's wider. So wider this way, because wider is not a problem. Because here width, HGA 20CA, width is 44. 44 millimeters, which is 1.5 inches, a little bit over 1.5 inches, inch 3/4. That's a wide block, boys. I like it. I like it a lot. All right, so let's go ahead and continue here. So let's look. Oh, and also I'm uploading video, by the way. But here's the deal, we only want one, so we'll have to find a way to only get one block that's loaded on there. Okay, so let's see, what does it have to hold? Okay, so here's E. E is the hole. Oh, E's from the end. So E from the end. E is 20 millimeters. So let's go here. 20 millimeters. 20 millimeters from the end. And the diameter we'll need later, but we need P. So P 60. 60 millimeters. Okay. Then we're going to need to put points. Come on. Points always glitched out on this. I don't know why. Come on. Super annoying. Oops. I guess P is not for point, P is for project. There it goes. There we go. Okay, so now let's do a rectangular pattern. What did I say it was? 60? So this is spacing 60 millimeters. Wait a second. Wait a second. Let's go ahead and close this. Direction this way. Why does it only look like? Tiger. Flush this object. Okay, so there we go. Obviously this is not going to be there. Shh. Okay, so now we're gonna want the D diameter 9.5, but the hole D small is 6. So let's just put a 6mm hole for right now, and then we'll figure out later on what that is. Obviously we're going to want as big of a, well, basically what we need to look at is a hex head that's small enough to fit in that hole, pretty much. 6mm. And then this we're going to have, what's 6mm? Let's have it 1/2 inch in. So the other thing also is that we're going to do T-slots in here, but we don't need to make them that deep because we don't want them to go into these screw holes. But even a 1 inch deep, let's see. Half an inch should be fine. But actually, we need it to have about a 1/4 inch clearance for even a bottoming tap. 1/4 inch, I mean. So let's just do that. And let's do create mirror features. Oh, it already had it. Features, mirror plane. Here we go. Looks good. Okay. Alright, so now we have the holes for our pillow blocks. And also, what's the thickness of this guy? 1 inch, and this thickness was width. It's 44. 44 is 1.7. So basically, we're gonna have some room for the feet. So that's probably the biggest I would go. And how much for these? Is it this one? Where'd it go? 130mm. There's 200 bucks. I think that's a pretty good deal. So let's see. And this is definitely going to add some stability here. This is 25 inches, which is basically the size of our cabinet. So let's go here. 25 inches, 635. So we need about half that. About 650. So let's look at and then this is going to be a 650mm. There we go. $650 HGHCA. There it is. But I believe these are still well, it says 2-piece linear guide and 4-piece, so yeah, it's still 2 per carriage. So we could probably get this down to about $100, probably about $100 a piece. And it's 2 rails, so that's really, really good deal. So I like that so far. So let's maybe I'll try to Google the what's it called, the diagram for this. Also, what's the width of the rail? It's 20mm. Whoa. That's about 3/4 of an inch. It's not that big, but I think it's okay. So maybe we might find something that's the same block size, but a thicker rail on the inside. And then what about the height? Height of the rail. You don't get the height of the rail? I mean, it's basically h minus t. Yeah, it's basically h minus t. It's about 22, pretty close to 22. This is about 0.8. And again, we want to minimize that. We want to minimize this. We want this guy to be as close to here because then there's going to be less torque on it. So let's see. So here's MP, so back and forth. That's going to be really, really high. Huh, it's not as much as MR. Interesting. Oh, because it probably doesn't have any bearings that run on top of the race. It has bearings that run on the side of the race. MG, was it? MR. MR is 0.27. Goes all the way to like 9 something. And again, remember, we're dealing with like 5 pounds of force or so. Some very small cuts. So, and it's going to take a long time, but I'm only planning on building like one of these a day at the most. So it's perfectly fine. So these are just longer. Yeah, but the CA is probably the biggest we're gonna go. Okay, so yeah, so maybe we can find one with a bigger rail here and same length, bigger rail, same length, and same maybe even smaller height. So bigger rail, smaller height here. Get this closer so you get not as much moment down there when it's bolted. Alright, so oops, that's to my other channel, my car channel. So that looks good, so let's go ahead and save that. Alright, so now let's go ahead and model the spindle really quick, because we're not making actually that great a time, because I showed you guys that other piece. So let's go ahead and do circle. Oops. And let me bring this to my other one so I could see this guy. Does it have a length? I might need to scale. I might need to look at this image here, bring it in, because it does not give you a length. Oh. Okay, so let's go here. Oops. So let's go to this one. What did I do? What did I do with it? Okay, so we know the height here, 65 millimeters. So let's go ahead and take this image and use that diameter and figure out the length there. So let's print screen. Paint. Hey, where'd my mouse go? Oh, there it is. Paste, go to my other screen. Cut that. Crop it. File. Save as. I wish you could just like I wish you could just copy and paste it or whatever. Okay. These are my videos from my car stuff. Documents, images, spindle. Wait, what happened? Oh, I need to select. There we go. Ooh, this is new, I think. I don't know the scale yet, so let's figure that out. Okay, so let's go ahead and go into Canvas, 60 watt spindle, let's calibrate. So let's say from here, so let's go across this line here. Or we go edge to edge here. There, to there, 65 millimeters. Okay. Oh, I guess I did click that. It's just like, it kind of lagged and I didn't see what happened. Oh, we want to delete that. Here. Okay, what is total length? So let's go from this section here. All the way back is what? 10 inches. Does that seem about right? This is pretty straight. Sure, let's go with that. So 65 millimeters. Oh, that's pretty small. Well, at least scale. And then this line was what? Shh, calm down. Calm down, Tegus. 9.6. 9.667. So let's see what that is in inches. I mean in millimeters. And we'll see if it's like a rounded number. Oh, consume that sketch. Let's open that sketch. 244 millimeters. Okay. And let's make this inches. Let's call this spindle. Hide that. Hide that. Let's call this 800 watt air cooled spindle. Because again, we're not using too much horsepower anyways, so we don't need a water cooling. That's just going to add more space and more issues. So basically what this is going to establish now, even though we're at the end of the video here, we're at 32 minutes, is that this is going to establish how long this gantry is going to have to be. So how high off the ground this gantry is going to be. And that we basically have a limit of the shelf size, which is 20 inches tall. So already we've lost 10 inches. So it could be a maximum of another 10 inches because it's got to fit. I mean, obviously this cabinet is 96 inches long, 25 inches deep, and 20 inches tall. So that's another thing. Is this 25 inches here? Yeah. So that's basically the idea. So now we know how tall it could be, which is, and then obviously we have a plug coming off here, so we got to clear the plug. So this is probably in actuality like 13 inches or something like that. And then this is an inch. So we have about 8 inches of clearance. But again, I only need like, 5 inches of clearance. So that's basically from the bottom of the cutter, but the cutter's got to be about 3/4 of an inch. So that's another inch. So it's 10 inches plus an inch plus a little bit of a foot. Let's call that another inch because we'll put some anti-vibration stuff on there. So 1 inch, 10 inches plus another inch for the cutter. So we're at 12 inches. So now we have 1 inch for the plate. So we're at like 7 inches. So we have plenty of space. And then whatever's left for the cable. So maybe the minimum that we need is about 5 inches. we'll have like a 5-inch table, or we'll find something with maybe a smaller spindle size, or build some sort of special 90-degree plug or something that comes off of this thing. Break the plug open and do a 90-degree plug where that plug is coming out of the side there. Otherwise, that looks pretty good. Oh, and this is 220 volt. Oh, it asked you for 110 or 220, so I'd probably just run 110. I mean, it's 800 watts. 800 watt divided by 110. 7 amps. It's not going to be as efficient because of 220. 220 is 6.5. What? Doesn't make any sense. That's 14. It's probably talking about at that efficiency, which is 0.6. Yeah, so it's about 0.56 efficiency at max horsepower, at max power. So that's why it's saying it's 0.8 kilowatt. Speaking of which, what is that? 800 divided by 1430. It's about 60% efficiency. So, but I think it's just rounded down. So I'm thinking that this is probably what it actually is, about 858 somewhere at max horsepower. But obviously we're running it more towards max speed, so we're gonna get more efficiency, and we don't nearly need 800 watt. We need 750 times, I think it was 0.2 horsepower. We need like 150 watt, so that's almost 5.5 times the power that we actually need. All right, so everything's looking good. We have a lot more stuff figured out. We have spindle kind of decided on. We have the base decided on. We have the rail decided on. We have kind of the width of this thing. So now we need to model in the rail here and the rail on the other side. And we need to do the uprights and the holding and kind of file in more of the height there, figure out the feet and the vibration stuff that we have, and we'll probably just use the same blocks over here, so the same rail. So it's another but these are shorter. These are only 12 inches, whatever. So they're going to be quite a bit shorter, so they don't really need nearly as much room. So that's pretty good. All right, so that's basically all I wanted to talk about here. All right, so I'll be doing another video later on today, and I will probably upload this video, the first video of this series, and then tomorrow I'll upload the next one, and then the next one, and the next one. Probably no more than one per day because I want to stretch it out so I keep showing you guys content. Okay, so we're at almost 40 minutes here. Obviously a few minutes over because I'm not going to do one right after this. So I wanted to get everything out. And then when I get back from work, I'll do probably a couple more. Do one more, take a break, work on something else. And then maybe an hour later or something, a couple hours later, do another one. Alright, so I'll start uploading these videos. And thanks for watching. And I'll see you guys next one. Take it easy. Peace.